Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 5, Identical Triangles. Okay, so opening exercise says, when studying triangles, it is essential to be able to communicate about the parts of a triangle without any confusion. The following terms are used to identify particular angles or sides. So we're going to use the term between, adjacent to, opposite to, and included sides and angles. So exercise 1 through 7 says to use the figure triangle ABC to fill in the following blanks. It says angle A is blank to sides AB and AC. So let's just start out by remembering how to name a side AB. AB with a segment over the top of it means line segment AB. Line segment AB means a segment that starts at A and ends at B. So therefore, this red segment, this side here, is side AB. I'll just mark that with red here. Side AC is the segment that starts at A and finishes or terminates at C. So that is this side. So there's side AB in red, side AC in green, and it says angle A is blank. Okay, is it between, adjacent to, opposite to, or included angle? Okay, and the way it's worded, angle A is blank. It's between sides AB and AC. So angle A is in between these two sides. Say between. Okay, I'm going to erase this. We'll start again. Angle B is blank, side AB. So here's side AB. Now we're talking about BC. I'll use blue for BC. BC is right here. This is BC. Angle B is blank, side AB and to side BC. So now this is saying it's between the two. This is saying you wouldn't say between AB and to side BC. So the wording is a little bit different here. And we're talking about angle B here. And it is adjacent to. So it's adjacent to side AB and it's adjacent to side BC. The wording, the and to there just makes it a little bit different. So adjacent means next to. So if I just got rid of that blue line there, this angle here is made up of that side, so that it's next to that angle. That angle is next to this side. Okay, next one says side AB is blank. So side AB is right here. And angle C is right here. So they're not adjacent. BC is adjacent to C. AC is adjacent to C. And C is between AC and BC. This, if we go looking straight across like this, that is opposite. Okay, next one. Side blank is the included side of angle B and angle C. So here is angle B. Here is angle C. All they're asking for is which line segment goes from angle B to angle C. And it's line segment BC. So I'd say side BC is the included side of angle B and angle C. Angle blank is opposite to AC. So side AC is right here. Angle A is adjacent to this side. Angle C is adjacent. So the only one left is this one here. So if it's looking straight across, then that is angle B. If you're a baseball fan, home plate is adjacent to, or is opposite, angle B is adjacent to the first baseline. Angle B is adjacent to the third baseline. And angle B is opposite the outfield wall or fence. Okay, that's one way to think about it. Okay, side AB is right here. It is between what two angles? So the segment names the angles that create it, so A and B. Okay, and then finally, what is the included angle of sides AB and BC? So what angle is included in those two sides? And it's the letter that's being repeated. There's a B, there's a B, so the answer is angle B. Angle B is the included angle with those two sides. Okay, so it says now that we know what to call the parts within a triangle, we consider how to discuss two triangles. We need to compare the parts of the triangles in a way that is easy to understand. To establish some alignment between the triangles, we pair up the vertices of the two triangles. We call this a correspondence. Specifically, a correspondence between two triangles is a pairing of each vertex of one triangle with one and only one vertex of the other triangle. A correspondence provides a systematic way to compare parts to two triangles. In Figure 1, we can choose to assign a correspondence so that A matches to X, B matches to Y, and C matches to C. We notate this correspondence with double arrows. So we would say A double arrow X, A corresponds to X, B corresponds to Y, and C corresponds to C. This is just one of 6 possible correspondences between the two triangles. 4 of the 6 are listed below. Find the remaining 2. So I'm going to color code these to show you what they're doing. So here they're saying A is to X. So here's A, here's X. B is to Y. So I'll put 2 marks for B, and that's to Y. And C is to Z. Okay, there is one correspondence. Okay, now they've changed it, and they're going to correspond A to Y instead. So this is the new one. So now they're going to correspond A to Y. So A has 1, so Y only should have 1. So I'm going to get rid of these marks here, but I'm going to leave these the same. So one arc goes to A, and A corresponds to Y, so I'm going to put 1 mark here. B is corresponding to X now. So now they're going to say B corresponds to X, and C didn't change. C still corresponds to C. So that is the second correspondence here. Okay, and now there's a third one. So I'm going to keep my A, B, and C the way I've had it. And I'm going to get rid of these arcs here. And I'm going to start again. And A corresponds to X, which would be here. B corresponds to Z. So this 2 marks goes to this 2 marks. And C corresponds to Y. C corresponds to Y. C has 3, so I put 3 up here. So we're just rotating angles, triangles around and corresponding different angles to different. We're not saying they're congruent or anything, we're just corresponding them at this point. And then the fourth one, I'm going to leave A, B, and C right where they are. But now we're going to correspond A is to Y. A is 1 mark, so Y gets 1 mark. B goes to Z. I put 2 marks on B, so C is going to get 2. And then C corresponds to X, which gets 3 marks. Now it says there are 2 remaining. So I'm going to write A, B, and C, X, Y, Z 2 times. We never change the letters, we're just changing the correspondence arrows. Okay, so we have to think about what we've done and what we haven't done, what we need to do. So I'm going to, let's use green. All right, so now we have A goes to X, we have A going to Y, we have A going to X, we have A going to Y. We've never had A going to Z. So A went to X here and here, A went to Y here and here. So I'm going to correspond A to Z. I've never corresponded A and C, so we're going to correspond A and C, A and C. B went to Y, B went to X. B went to Z, B went to Z. Okay. So this is where it gets a little tricky. We want B to go to X and C to Y, and then we want them to switch. So B is going to go to X, and therefore C has to go to Y. Or we could have B go to Y, and C go to X. Okay, and those are the final two correspondences. Now this is a real confusing way to do this. So down below, we're going to go over it one more time, and it's a simpler way, as this says. A simpler way to indicate the triangle correspondences is to let the order of the vertices define the correspondence. For example, the first correspondence is to the first, the second to the second, and the third to the third. Correspondences above can be written in this manner. So let me show them still. So we have A is to X. So A is first, X is first. B goes to Y. B is second, Y is second. And finally, C goes to Z. C is to Z. That is this one right here. Now, if I keep doing that, I'm just going to point this out to you. A goes to Y. So that's where A is first, Y is first. B is second, X is second. And C is last, C is last. So the order of the letters is the name of the correspondence. Okay, so now we're going to make the last two that haven't been made. And I'm just going to draw a triangle ABC with my double arrow and then a triangle symbol. So this one here, A is going to Z. So I'm going to put Z first because A is first. Then we have a B, and B goes to X. So X comes next, and then finally C goes to Y. One more time, triangle A, B, C corresponds to triangle, and I look up here, A is, I'm over here now, this one here. A corresponds to Z, so since A is first, Z is first. B corresponds to Y, B is second, Y is second, and C corresponds to X, and that goes just like that. Now it says which, with a correspondence in place, comparisons can be made about corresponding sides and corresponding angles. The following are corresponding vertices, angles, and sides for the triangle correspondences where triangle ABC corresponds to triangle YXC. Okay, so we're using YXZ, so we're using this one here. So vertice A goes with vertice Y, vertice B goes with vertice X, and vertice A goes to vertice C goes to vertice C, or vertex. Angle A corresponds to Y. Angle B corresponds to angle X, and angle C corresponds to angle C. Okay, and then the sides. Get rid of this here. Now when we're doing sides, if I choose AB, it's right here. So they said AB. Those are the first two letters of the name of that triangle. The first two letters of the corresponding piece are YX. So therefore that's why we have that way, AB to YX. Now if I move this over to BC, that's the last two letters of this three-letter name. If I move that one over, now we have BC is to XC. I'm going to put XC. Put a line segment over the top. Okay, now finally we're going to be careful with our ordering. They're going C and then A, 3 then 1. So 3 then 1 is C, Y. So this is C, Y segment. Okay. All right, example 1. Given the following triangle correspondences, use double arrows to show the correspondence between vertices, angles, and sides. So triangle correspondence, triangle ABC corresponds to triangle STR. So ABC corresponds to STR. Correspondence of vertices. Okay, I'm just going to look at the letters. I don't use the diagram. You can if you want to. I'm just going to use the letters. It's easier for me. I prefer it. It just seems to be quicker. So the correspondence of vertices would be, now vertices, we just use a letter and no angle measure. Vertice A is to S. So I do a double arrow and S. Vertice B is to second letter T, and vertice C is to vertice R. Correspondence of angles is going to be angle A, angle B, angle C, and we're going to write the correspondence arrows, double arrows. Angle A corresponds to angle S. So the vertices and the angles are the same, but we just have to put the angles in. Okay, so angle S, angle T, and angle R. And finally, the correspondence of sides. Okay, so if I use the first two letters, AB, side AB corresponds to side first two letters, ST. Okay. Then if I use the second two letters, BC, side BC, corresponds to side, last two letters, TR. And they have to be in that order. You don't want to say RT. It is TR. Same order as in the name of the triangles. And then finally, if I'm going to use the first and the third, that's AC. And that corresponds to the first and the third, which is SR side. Okay. Okay, examine figure 2. By simply looking, it is impossible to tell the two triangles apart unless they are labeled. They look exactly the same, just as identical twins look the same. One triangle could be picked up and placed on top of the other. Two triangles are identical if there is a triangle correspondence, so that corresponding sides and angles of each triangle are equal in measurement. In figure 2, there's a correspondence that will match up equal sides and equal angles. Triangle ABC corresponds to triangle XYZ. We can conclude that triangle ABC is identical to triangle XYZ. This is not to say that we cannot find the correspondence in figure 2 so that unequal sides and unequal angles are matched up. But there certainly is one correspondence that will match up angles with equal measurements and sides of equal lengths, making the triangles identical. So what they mean is I could have said triangle ABC corresponds to triangle CYX, even though we corresponded angles that are not congruent, the triangles would not sit right on top of each other. We could still make a correspondence of unequal pieces. So in discussing identical triangles, it is useful to have a way to indicate those sides and angles that are equal. We mark sides with tick marks and angles with arcs if we want to draw attention to them. If two angles or two sides have the same number of marks, it means they are equal. So in this figure, AC is right here. There are two marks. DE is down here and it had two marks. And EF is up here and it had two. So that means AC is equal to DE and equal to EF. All three are equal. Okay, so then it says angle B. Notice there is one arc here. And there's one arc here. So angle B is equal to angle B. Example 2. Two identical triangles are shown below. Give a triangle correspondence that matches equal sides and equal angles. Okay, I'm just going to mix this up a little just to explain to you that naming a triangle does not have to be in alphabetical order. It does not have to go clockwise. It can go counterclockwise, and you can start with any letter. So I'm going to start at the top, and I'm going to go counterclockwise. I'm going to call this triangle CAB. So I'm going to say triangle CAB corresponds to triangle. Now C has two marks. If I look over this triangle and the one with two marks is R, so that's got to go first. Then I have A. A has one mark. I come over here. T has 1 mark, so T comes second. The last angle name is B. B has 3 marks, S has 3 marks, so S has to come third. So all I'm trying to explain to you is, no matter what we name the first one, the same pieces are always going to correspond. So if I rename this and I called it something else, let's just call it ABC now. Triangle ABC corresponds to triangle. Now the A went to the T, so it still will. The C went to the R, it still will. And the B, hang on, the A, let me go in the right order. The A went to T, and it still will. The B went to S, it still will. And the C went to R, so that's going to go like that. So what we're saying is A went to T, A still goes to T no matter how I name it. C went to R, C is the last, R is the last. And B went to S, and B is the middle, S is the middle. So no matter how I rearrange these, if I rearrange one of the first letters of the first triangle, I have to move the second triangle's name around so they still line up. Okay, exercise 8. It says sketch 2 triangles that have a correspondence. Describe the correspondence in symbols or words. Have a partner check your work. So I'm just going to grab my ruler really quickly here. And I'm going to draw a triangle. And I'm going to just go like so. Again, it didn't say anything about these 2 triangles having to be congruent. So there's a triangle. I'm going to call it triangle A, B, C. Okay, and then I'm going to draw another triangle over here. Okay, so what I've kind of done was drawn 2 triangles. Now let me just say that, let's say A is the same as X. I'll put 1 mark. And I'll say B is equivalent to or equal to Y. So I'll do this here. And then I'll say C is equal to C. I didn't take time to use a protractor to make these exact. I'm just saying that's our correspondence. The side lengths may be different, but the angles are congruent. So I could say triangle BCA. So this time I started at the top and I went clockwise. It does not matter how you name the first triangle. It matters how you correspond the pieces of the second to the order of the first. So B has 2 marks, so I want the 2 mark angle, which is Y. C has 3, so I want the 3 mark one over here, which is C, one of 3 arcs. And A comes last, and A has 1 arc, and X has 1 arc. So there would be my triangle correspondence. Triangle BCA corresponds to triangle YCX. Okay, that is the end of lesson 5. Go do your problem set.